Welcome to the annual Timbit Toss and Catch hosted at Trinity Western University. This long-awaited event has quickly approached in all of its jelly-filled, sugar-coated glory. Let's review the rules for those just tuning in. A tosser from each team will get a chance to toss a single timbit of their flavor of choice out of the tossing frame towards their teammate and the opposing catchers down below on the catching field. During the toss, the catchers will not be permitted to move and will have to catch the timbit with their mouth. The tosser is aiming to have their teammate be the one to catch the timbit. This is a science of projectile motion and also chemistry between the two teammates. Let's have a look at Team Canada's last throw of the day.
Here we have a timbit moving out of a window into the mouth of a fellow Canadian. First, the setup itself. The timbit is initially situated at the top of the window, which is 5.58 meters from the ground. However, we need to subtract the height of Philip from Team Canada, who caught the timbit, and he is 1.68 meters tall. Therefore, the timbit is traveling a total of 3.9 meters vertically. All these measurements were calculated through capstone. On the contrary, the timbit is not only traveling in a vertical direction, because this is a projectile. To calculate the horizontal direction, a simple measurement was taken from the building to the exact position of Philip. Using capstone, this calculation was 5.85 meters.
The angle at which it was thrown was 24.89 degrees. Its initial velocity was 2.39 meters per second, which was used to calculate the change in time. And its final velocity was 5.15 meters per second, used to calculate the horizontal distance.
The similar aspect between the horizontal and vertical distance would be the time in which the timbit travels to the air. Using a kinematic equation, the time it took the timbit to travel from Steve to Philip, both from Team Canada, was 1.168 seconds.
By subtracting the accepted value for acceleration by the value we found for acceleration. So in this case, negative 9.81 minus 8.52, and then multiplying that by the weight of the timbit. This gave us our value of air resistance.
The theoretical value for the horizontal distance was greater than the experimental value found using capstone. This makes sense because the air resistance works against the direction of the toss, and therefore, from experimental results, the timbit traveled a shorter distance.